Hi, my name is Junyun Jong from Neighbor Cloud and KAIST. In this video, we are going to share our research work, named as ProxyDet, Synthesizing Proxy Novel Classes via Classwise Mixup for Open Vocabulary Object Detection. This work explores an efficient training strategy that can effectively learn the representation space of novel classes for open vocabulary object detection task. So today we are going to briefly talk about the definition of our target task, open vocab object detection, and the problem with motivation behind our work. Also, we are going to introduce some related works that dealt with our problem statement. And then we will introduce our proposed method with intuitive experimental results. Open vocabulary object detection task aims for detecting the novel class objects that are not seen during training phase. While conventional closed-set object detection task can only detect base classes that are seen during training phase, open vocabulary object detection can detect not only base classes but also unseen novel classes during inference phase, even though they were not seen during training. Since open vocabulary object detection can detect various novel class objects, it can be generally used as a preliminary step for various downstream vision tasks. For example, it can be used for zero-shot image editing, where we should identify the location of the novel classes, such as Labradoodle, and edit the style of them. In order to achieve open vocabulary property, several OVOD frameworks adopted massively pre-trained vision language models such as CLIP. So the first step is to localize with the class-agnostic RPN, and it can localize any of objects, including novel class objects. Secondly, each of box proposals are vectorized by detector head and classified by calculating cosine similarity with text embeddings of all the classes, including novel classes. To further improve the performance of detecting novel classes, knowledge distillation from CLIP image encoder is proposed, where the CLIP image embeddings sourced from RPN proposals are distilled into the detector. As a result, the detector is supervised to be aware of novel classes. In order to further explicitly expand the range of detection vocabulary on the novel classes, several works relied on pseudo-labeling, a subset of novel classes given in the inexpensive supplementary datasets, where the image-level labels are given and box annotations are missing. The missing box annotations are pseudo-labeled by selecting the max size proposal from RPN, and its corresponding class label is given by image-level label. However, although these pseudo-labeling approaches achieved great performance improvement on pseudo-labeled novel classes, they showed limited generalization on truly unseen novel classes, which are non-pseudo-labeled, as shown in below table. To overcome this limitation, we present ProxyDet, a new OVOD framework that aims for helping better generalization on the overall distribution of novel classes, including these truly unseen novel ones that have never been presented during training, as shown in below table. For achieving our goal, we found that an intuitive relationship between base and novel classes. Specifically, a wide range of novel classes resides within the convex hull constructed by the base classes in the VLM embedding space, as shown in below figure. Motivated by this observation, we propose a synthesis of proxy novel classes, which approximates novel classes via convex combination between the base classes, as shown in below figure. Notably, we observe that the overall distribution of novel classes can be better approximated through our proposed proxy novel synthesis compared to the framework where only base classes are given for training, as shown in left figure. Also, learning on these proxy novel classes provides an extensive proximal exploration of numerous novel classes during training, as shown in right figure, thus effectively expanding the detection vocabulary. As a preliminary step for synthesizing proxy novel classes, we obtained box proposals and corresponding region embeddings of base classes from RPN and detector head, respectively. Next, we obtained textual prototype embeddings of base classes using CLIP text encoder. By applying convex combination between the visual prototype embedding of base classes, we newly synthesized visual representation of proxy novel class. The way of constructing visual prototype embedding is a crucial factor in synthesizing sophisticated representations of proxy novel class. A simple solution is to average all the region embeddings corresponding to each base class as the left figure. However, this naive solution could be suboptimal since the low-quality proposals, such as red color boxes, can equally contribute to construct the prototype. Therefore, we propose to conduct weighted summation with box quality-aware measures, such as objectness score and IOU score with ground truth boxes. By doing so, our proxy novel synthesis is conditioned on more robust prototype embeddings, which can more precisely estimate the class-wise representations with respect to the base class. Likewise, by applying convex combination between the textual prototype embedding of base classes, we newly synthesized textual representation of proxy novel class. Finally, we regulate the distance between the newly synthesized visual and textual embeddings to be close to each other, which helps to explore a proximal representation space of novel classes. For experiments, we evaluated our proposed framework, ProxyDet, on open vocabulary detection datasets such as OpenVocab LVIS and OpenVocab COCO. On both datasets, we achieved the best performance on APR, which is the performance on novel classes, compared to the previous works. Also, we tested transferability on other detection dataset, where we trained on LVIS and tested on other datasets such as COCO and Objects 365. Notably, we clearly achieved best transfer performance on COCO dataset, trailing right behind the supervised case, which is trained on the target dataset. Furthermore, our ProxyDet achieved similar to the best performance on Objects 365, while clearly attaining superior performance on rare classes. For ablation studies, we analyzed the effect of prototype-based mix-up in the left table. The instance-wise mix-up case in the second row highlighted in red, it did not leverage visual prototype embedding, and the performance improvement was marginal. Since this instance-wise mix-up blends individual instances of region embeddings for each base class, it comes with the drawback of incorporating the noisy embeddings from low-quality box proposals into the mix-up without any form of filtering, which might impede stable training. In contrast, leveraging visual prototypes largely improved performance, while weighted summation with box quality-aware measures such as IOU and object scores further improved performance. Secondly, we analyzed the effect of Classwise Mixup, where the second row denotes leveraging visual prototypes but without Classwise Mixup, and its performance improvement was marginal. However, when mixup is applied by sampling mixing coefficient lambda from beta distribution, it largely improved performance. We also further analyzed the ideal case of our proxy novel synthesis to better approximate novel classes. Rather than mixing the base classes randomly, we selected the optimal combination of base classes for each novel class and conduct class-wise mix-up. The result in below table shows that the ideal case indeed brought much larger improvement on novel classes. However, this ideal case is impractical since the novel categories are not known during training phase, and hence we cannot select the optimal combination for each novel class. Therefore, enlarging the set of prior vocabularies for mixing to ideally cover all the novel categories is a practical alternative, which is our future work. To conclude our work, first we empirically observed that novel class representations can be effectively approximated through mix-up between base classes. Based on this observation, we proposed a new synthesis of proxy novel class with well-defined prototypes of base classes, which helps to explore the embedding space close to the novel classes. Our extensive experimental results demonstrate the superior generalization of our method for detecting broad range of novel classes. This is the end of our presentation, and here are the QR codes for our paper and code materials. Thank you for listening.